Hi guys, assalamu alaikum. Today we will be solving the 20 most hardest Physics Unit 5 multiple choice questions. Without wasting any more time, let's get started. The first question that we will solve today will be this question. This is a very repetitive but difficult question. In the question they have said the fusion of nuclei of 56 iron in a star doesn't release energy. So it doesn't release energy. Why it doesn't release energy? They have asked a reason for why it is not releasing the energy. Now we all know from the graph that is present in our book. This graph is present in our book. This graph is about the nucleon number, or you say this graph is about the mass number and binding energy per nucleon. This is the graph that we have in our book as well. Binding energy per nucleon and mass number. So here at the top the graph is like this. The graph is like this. And in this reaction there is Fe56 right here. This is 56 Fe. So this is the most stable iron which doesn't release energy. Any mass number or any binding energy per nucleon less than 56 will undergo fusion, and greater than 56, or in this part, or mass number with greater than 56 will undergo fission. So this is what happens. Okay, as iron 56 has the highest binding energy per nucleon. Iron 56 has the highest binding energy per nucleon, and anything which mass number is less than 56 will go fusion, and anything which has the greater mass number than 56 will undergo fission reaction. But iron has the highest binding energy per nucleon, that's why it doesn't release energy. It doesn't require to undergo fission or fusion because it is the most stable state. Okay, so what is the reason they have given? The magnitude of nuclear binding energy is the least. No, it is not about the least. They are not the least. They have also said here least. They are not least. These two are the greatest. They have given greatest. But out of B and D, only one will be the correct answer. In the B part, they have said the magnitude of nuclear binding energy is the greatest. No, the nuclear binding energy is not the greatest. It is the binding energy per nucleon is the greatest. That's why this is our correct answer. So our correct answer will be D. Now moving forward to the question number 4. This is a typical Physics Unit 5 question. They have said a student measured the temperature of 0.015 kg of wax as it cooled and changed state from a liquid to solid. So it is changing its state. It is changing its state. So we all know during the state change there is no temperature change. During the state change, temperature remains constant. Temperature remains constant during the state change. The temperature remains constant. The temperature remains constant. They have given us the rate of 25 watt. Rate means energy divided by time taken. Okay, they have given the rate of energy transfer. The rate of energy transfer means anything is said about rate of energy transfer means energy divided by time taken, which means the power, and the watt also shows that it is talking about the power. Now what they have asked us to do is they have asked us to give a following expression for the specific latent heat capacity. Latent heat capacity. From this graph what we can look right now is we have said for when the state is changing the temperature remains constant. So in this part the temperature has been constant. In this part the temperature has been constant. So we have to take this time period. This is 50 to 150. That means it's 100 seconds. Between 100 seconds, for these 100 seconds the temperature remains constant. Here the state was changing. There's a state change take place from liquid to solid. The state was changing from liquid to solid. That's why at that time the temperature remains constant, and the time for that state change was 50 to 150. That means 150 minus 50 is equals to 100 seconds, right? This is the value. Now we have got our time. And we have the power as well. They have given us the power as 25 watt. So we can figure out the energy is equals to 250 to 25 into 100 seconds. time is 100 and power is 25. We have got our energy. Now when state change is happening, we know the formula that we need to use is energy is equals to m into latent heat of fusion. So here we have the energy as 2500 into mass into L, and they have asked us to figure out the specific latent heat. So L is equals to 25 into 100 divided by the mass, and they have given us the mass as 0.015. So basically this is going to be our answer. 25 into 100 divided by 0.015. This is our correct answer. Now let's move forward to the question number 7. In the question number 7, what they have given to us is a student is investigated the absorption of gamma radiation by lead. Okay, very good. As shown, with no observer. With no observer. The intensity of radiation was I naught, and when the thickness was made 0.8 centimeter, the intensity decreased to 0.25. So it became 25% of its initial value when a thickness of 0.8 centimeter was introduced. What thickness of observer would give an intensity of 0.5 intensity? So they're asking what thickness will give 0.5 intensity. So we know that when intensity was normal and when thickness was introduced, intensity decreased. So we can say the thickness and intensity is inversely proportional. As when the thickness was introduced, intensity decreased. That's why we are saying when the thickness increased, the intensity decreased. So we can say they're inversely proportional because at first there was no thickness. So when 0.8 was introduced, or when the thickness was increased from 0 to 0.8, let's say when it was 0, there was no thickness, and now it is 0.8. That means the thickness has increased. At that time the intensity has decreased from 1 to 0.25. So we can say they are inversely proportional. Sorry, my bad, I've written the wrong thing. They are inversely proportional. Yes, it's true, but it will be 1 divided by time taken. Okay, so if we break them down, we will introduce one constant, which is k. Now if we put this 0.25, I naught is equals to k divided by thickness was 0.8 centimeter. So now we will figure out our k value, which is k is equals to 0.25 into 0.8 centimeter. Okay, so now we have to multiply and figure out this k value. Just a minute. So this value comes as 0.2. This is 0.2 centimeter. Now we have figured out our k. Now we will again use this formula. We got our k as 0.2. Now we know intensity is directly proportional to 1 divided by time. Now we will use the intensity of 0.5 is equals to k divided by time, k divided by thickness. So when 0.5 is intensity and the k is 0.2, at that time thickness will be 0.2 divided by 0.5. which will be 0.4 centimeter. So our correct answer will be B. So basically we are done with figuring out the question number 7 as well. Now moving forward to the question number 9, which is a bit difficult question, one of the most difficult questions. An object oscillates with simple harmonic motion. The period of oscillation is 0.65 seconds and amplitude is this. Okay, they have given us the amplitude and the period of oscillation. They have asked us to figure out the maximum velocity. We know the maximum velocity is equals to amplitude into angular velocity. This is a normal formula, that maximum velocity is equals to amplitude into angular velocity. This is our amplitude and this is our angular velocity. We have got our amplitude as 0.12 into angular velocity is 2 pi divided by time taken, which is 0.65. Here we have got it. Now if we figure that out, we can say that this is our correct answer. This was just a formula math, nothing else. Quite easy. Alright guys, so let's solve this question number 5 right now. They have said a fixed mass of an ideal gas has a volume of V and exerts a pressure P. Okay, this is for a fixed mass of an ideal gas. This is for an ideal gas. Now the absolute temperature of the gas is T. Okay, when the gas is heated, when this ideal gas will be heated, the new pressure will be 4P. Okay, very good. So ideal gas has a pressure of P and the heated gas has a pressure of 4P. Now they are asking which row of the table gives correct values for the new volume and the new temperature. So what will happen to the new volume and new temperature when the gas will be heated? So for the ideal gas we can say PV is equals to NKT. And if you write PV by T is equals to NK, then these NK is a constant. These NK is a constant. This is for the ideal gas. This is for the ideal gas. Now let's write the same thing for the heated gas. For the heated gas we can say, for the heated gas we can say P2 V2 by time is equals to NK. Now this NK is constant, which is same for both the ideal gas and for the heated gas. So here we can replace these NK by these NK, which means NK is equals to PV by T. So we can replace it by this. What we will write right now is we'll write it like this, that PV by T is equals to P2 by V2 by T. So whatever happens to this value, it will always remain same as PV by T, because there is an equal sign right here. So if this pressure has become 4P, we can write it down as 4P into V2 divided by time is equals to PV by time. Now we have to look at how will this V2 and this temperature will change. Let's say we will look at for the question number B. In the question number B, they have said that V2 will become double by 2 and T will become 4 times. So if we make V2 2 times and 4 times, then if we cross multiply 4, then it will remain as V divided by T into this P divided by time, which is not equal to this PV by 2. So we can say B cannot be our correct answer. Now let's have a look at choice number A. If we make our temperature 2 times and volume half, let's say what we get. If we 2 it becomes 2, and if we cross multiply these 2 and these 2, then it remains as P into V divided by time. So our correct answer is A. You can try this in the same way for C and D to look if C and D is correct answer. You will find out that C and D is not the correct answer. Only the correct answer is A. When the volume is half and the temperature is doubled, at that time the whole value becomes PV by T, saying that the pressure is 4 times. They have said it for us. So basically we are done with question number 5. Now in this question what they have said is the graph shows how the binding energy per nucleon depends upon nucleon number for a range of naturally occurring nucleates. So here they have given us the nucleon number or mass number, and this is the binding energy per nucleon. So iron 56 has the highest binding energy per nucleon. Okay, iron 56 with the mass number 56 has the highest binding energy per nucleon. Any element which has a mass less than 56 will undergo fusion, and any mass which has a mass number greater than 56 will undergo fission. Less than 56 fusion, greater than 56 fission. Okay, now in the first part they have said which of the following can be deduced from the graph. Iron 56 readily undergoes fission. No, it is the most stable state. It is the most stable state. He is in the most stable state. Iron 56 is in the most stable state. It doesn't go fission readily. This readily word is wrong, so A cannot be the correct answer. Now B, fission releases less energy than fusion. No, this is wrong as well. Fission releases more energy than fusion. When fission reaction is happening, it releases more energy than the fusion reaction, but the binding energy per nucleon for fusion is greater than the fission. That is the different thing. But for energy, fission releases more energy. So this is not the correct answer as well. You need to remember one thing as well, that binding energy per nucleon released for fusion reaction is greater than the fission reaction. But in terms of energy, what they are talking about, in that term, fusion releases more energy than the fusion. Okay, now in the second part they have said high mass nuclei cannot undergo fusion. No, this is not correct. These are the high mass nuclei which have a mass number or nuclear number greater than 56. They are saying that they don't go undergo fusion. No, they do go fusion, or they can be forced to go fusion by providing sufficient energy. You need to provide sufficient energy. It's very important to write them because it may arrive in your exam day in a different way. So make sure that you are knowing all the possible things. And in the 4 part, this is the correct answer, as all the others are not the correct. But I will not write it like this. I will make you guys understand why it is the correct answer. Low mass nuclei release energy during fusion. Yes, these are the 56. Any mass less than this will undergo fusion. So this is our correct answer, that low mass nucleus which have low mass. Low mass means, as 56 is the main point right here, so anything below it will be called a low mass nuclei. So we can say low mass nuclei releases energy during fusion, so they undergo fusion. And anything above 56 is said as high mass, or yeah, so let's say we can say they are undergoing fusion. So our correct answer is D. A communication satellite has a mass of 935 kg. The satellite has an orbital radius 4 times the radius of the Earth. So this is the important thing. They've said that it is 4 times the radius of the Earth. So let's draw the radius of, let's say this is the Earth, and this is the radius of the Earth, which is R, and this is the orbit at which the communication satellites will be orbiting. Let's say there is a communication satellite. So it has a radius of 4 times the Earth. So this has a radius of 4 times the Earth. So let's say R1 is equals to 4R. Okay. Now, which of the following gives the gravitational pull of the Earth on the satellite in the orbit? Okay. Gravitational pull. So they're asking about the force that is Earth exerting on the satellite. So we can write F is equals to Gm, the satellite's mass, divided by the R squared. Here the R squared will be 4R squared because the radius is 4 times. So we can say this is 4R squared. Now it will become Gm by R squared into mass of the satellite divided by 16. This 4 squared becomes 16. We have written it like this. And this Gm by R squared we know is G. We know the formula of G is equals to Gm by R squared. Okay, Gm by R squared. Sorry, my bad. The writing is not that good. This is Gm by R squared. And this G is 9.81. So we can write it down here, that 9.81 into mass of the satellite divided by the 16. And mass of the satellite has been given as 935. So it is 9.81 into 935 divided by 16. This 9.81 is from Gm by R squared, and we know Gm by R squared is G, and this G is 9.81. So we have written 9.81 into mass of the satellite divided by 16. This is the value that we get. The overall value will be 570 Newton. So our correct answer is B. Now moving forward to the next question. Our next question is the question number 7. In this question they have said a fixed mass of gas occupies a constant volume. Okay, the temperature of the gas is increased. Which of the following is not increased? Which of the following is not true? So they are asking which is not true. So we know when the temperature increases, the average kinetic energy of the molecule increases. So yeah, it's correct. When the temperature increases, this temperature is directly proportional to kinetic energy, average kinetic energy. So when the temperature increases, the average kinetic energy also increases. So when the average kinetic energy of the molecule increases, the internal energy also increases. So this is correct as well, because when a fixed mass of gas is in a constant volume, at that time they doesn't have any potential energy, they only have the kinetic energy. So if the kinetic energy increases, the internal energy also increases. We can say this is correct, but they are looking for not true answer. The pressure exerted by the gas increases. We know PV is equals to NKT. If the temperature increases, then the pressure will also increase because they are directly proportional. So we can say this is correct as well. So basically this is not true and this is going to be our answer. But why? Why they have said the mean momentum of the molecule increases? You could have said that p square is equals to p square by 2m is equals to kinetic energy. So if the kinetic energy increases, the p square will also increase, the mean momentum will also increase. So it's a correct. No, this is not correct. Why this is not correct? Because they are saying in a constant volume or in a constant container, the average velocity is equals to 0. In a constant container, the average velocity is 0. And we know average momentum is mass into velocity. So if velocity is 0, then the mean momentum will not increase. The mean momentum will not increase. The mean momentum will be 0. So we can say this is our correct answer because this is not true. In a closed container, if it was in a free space, then this situation could have been correct. But as they have said, in a constant volume or in a container, because in a container it's a constant volume, at that time the mean velocity is 0. And if the mean velocity is 0, at that time the mean momentum is also 0. So we are done with question number 7 as well. Now moving forward to the question number 8. What they have written here is, Boyle's law states that under certain conditions, the pressure exerted by a gas inversely proportional to the volume occupied by the gas. Yes, pressure is inversely proportional to the volume, and we can say P is equals to K by V. This is true. Okay, very good. 1 minute. Yeah, P is inversely proportional to V. It's true. The P is inversely proportional to V. And we can also say P is equals to K by V, and PV is equals to K. This can also be written as like this. Okay. Now, as they have said, so they have said which condition is not necessary. If pressure is inversely proportional to volume, which condition is not necessary? They have said the gas must be ideal. Yes, it's true. It's necessary. It's not necessary. It's necessary. So it's correct that the gas must be ideal, otherwise you cannot use the formula of PV is equals to NKT, where P is inversely proportional to the volume. PV is equals to NKT, or P is inversely proportional to volume, or Boyle's law is only applicable when the gas is ideal. So it's correct. The mean kinetic energy of the molecule must stay constant. Yes, the mean kinetic energy must stay constant. That means if the mean kinetic energy stays constant, then this temperature will also constant. So Nk is also constant. So P is inversely proportional to volume. There is only PV, which is changeable, because if PV is equals to NKT, Nk is constant, and the temperature must also remain constant for pressure to be inversely proportional to volume. Okay, so we can say the average kinetic energy is also constant, because the average kinetic energy always remains constant when the temperature remains constant. So temperature must remain constant for pressure and volume to be inversely proportional to each other. They have said the molecule in the gas must be identical. No, this is not correct. This is not necessary. So this is our perfect answer. Why it is not necessary? Because in PV is equals to NKT formula, we have never seen anything like this, that they never said that the molecules needs to be identical. The molecules can be of different types, that doesn't matter. Okay. The fourth point is the number of molecules in the gas remains constant. Yes, the N needs to be remaining into constant. So yeah, the only correct answer is C. The other ones are correct. The only not necessary answer is C. Okay. Now moving forward to the question number 9, they have said bismuth decays to form an isotope of thallium. So bismuth is decaying, it is decreasing, and the thallium is forming. As it is forming, it will increase. So this is how the number of thallium atom in a sample of bismuth varies. So how the number of thallium atom is varying. So the number of thallium atom is increasing, right? As it is forming, its number of atom is increasing. So in these two parts, they have give decreased. They have seen that the number of thallium is decreasing. So these two cannot be our answer. Either of them will be our answer. So here they have said it is increasing in an increasing rate, and here I have written that it is increasing in a decreasing rate. D is our correct answer. Why D is our correct answer? Because when the thallium is increasing, it will increase in a decreasing rate. Because why the rate will be it will increase, the number of thallium atom will increase, but the rate will be in a decreasing rate. Why decreasing rate? Because at the first, when bismuth was decaying, it had a high concentration, but as the time has progressed, its concentration has decreased. That's why the rate of increase will also decrease, but the number of thallium atom will definitely increase. That's why our correct answer is D, and you should not mess this up with the answer of C. Answer of C is not our correct answer. I'm making you guys understand again. The thing is, at the first, when bismuth started to decrease and the formation of thallium started, Okay, when the bismuth was decaying and the thallium was forming at that time there was ample amount of or abundant concentration of bismuth. That's why the formation of thallium was at a certain rate. But as the time progressed, as the time progressed, as bismuth has decayed few much, at that time its concentration has decreased. We know rate is equals to concentration divided by time taken. So as the decay progressed, as the time progressed, this concentration decreases as well as the rate decreases. So when the rate decreases, it decreases rate. So we cannot write that the rate is increasing because the concentration of bismuth is not increasing. The concentration of bismuth is decreasing. That's why the rate of formation of number of thallium atoms will also decrease. That is the main reason of question number 9 being D and not C. I hope you have understood this question number 9. If you don't, then please let me know in the comment box. I will make you guys understand again by writing them down for you guys. Thank you guys. Alright, the graph shows how the binding energy per nucleon varies with nucleon number A for low mass nuclei. So as we have seen this type of questions twice, this question wouldn't be a problem for you guys, but I'm still showing this question so that you guys can understand this part very easily, because this type of questions will be there in your exam in the January 2025 and May 25 exams. So there the binding energy per nucleon has been given, and they have also given us the A, which is the mass number. Okay, they have said which of the following is the energy required to split a helium nucleus into 2 protons and 2 neutrons. So basically what they will do is they will split one nucleus into its constituent particles or into its constituent nucleons. So splitting a whole nucleus into its constituent particles requires binding energy. Okay, so this is the energy required. This energy required is named as binding energy. So binding energy is the energy required to split a complete nucleus into its constituent particles, because a helium 4 nucleus is composed of 2 protons and 2 neutrons. So basically what they will do is they will break down this whole nucleus into its nucleons, and it will require energy. That required energy is known as the binding energy. And they have given us the binding energy per nucleon. We know the formula: binding energy per nucleon is equals to binding energy divided by the number of nucleons. So this is the formula we have learned in our syllabus. So basically they have given us the binding energy per nucleon of helium, which is around, no, which is not helium, this is helium 3, my bad, we have to look after helium 4. This helium 4 is around 7.1. we can take it down as 7.1 or even 7.05, not an issue. I will take it as 7.1. You can also take it down as 7.05. So binding energy per nucleon is 7.5 is equals to binding energy divided by the number of nucleons. As they have said it has only 2 protons and 2 neutrons, we can say it has 4 nucleons. So the binding energy will be 7.1 into 4. The correct answer will be around 28.4. Yes, mega electron volt. This is the correct answer. So yes, this is the correct answer. Our correct answer is D. Now we are done with it. So binding energy per nucleon, the energy required to split one nucleon is the whole binding energy divided by all of its nucleons. And breaking down a whole nucleus into its constituent particles is the energy, requires the energy, and that energy is known as the binding energy. So I've made you guys understand this in a very detailed way. If you guys still have any problem, ask me in the comment box. I will answer them for you guys. Or you guys can also message me in my WhatsApp account. The WhatsApp account will be given in the description box. Now in the question number 10, a mass oscillates with simple harmonic motion. Okay, very good. It is oscillating. The graph shows the acceleration, mass acceleration and displacement from the equilibrium position. This is the acceleration and this is the displacement. And this graph is like this, right? So we know one formula of this graph, that is A is equals to minus omega squared x. First of all, A is directly proportional to x, negative x. And when you break down this directly proportional sign, it becomes A is equals to minus omega square x. So here they have given a graph of acceleration and displacement. They have asked us to figure out the period of oscillation. So period of oscillations means time period, and there is only one formula which relates time period, is angular velocity is equals to 2 pi by dv dk. If you can figure out the angular velocity, then figuring out the time period is not an issue. So we have to figure out this angular velocity. So we know If we divide a divided by x, we will get minus angular velocity. So a divided by x means dividing the y-axis by x-axis means these minus omega square is our gradient. We can also write this formula like this as well. I'm not making things difficult for you. Y is equals to mx. If y is equals to mx, then m is equals to minus omega squared, right? M is equals to minus omega squared. So let's write it down right here. M is equals to minus omega squared. So we know omega is equals to minus omega is equals to minus 2 pi by time squared. So let's remove these minus forms and let's figure out y is equals to 2 pi by time squared. Now this angular velocity is the gradient right here. So to figure out the gradient, what we can do is we can find the regard 3.2. Actually it is minus 3.2 minus 3.2 divided by 0.2 minus 0.2. Minus 0.2 and minus becomes 0.2 and here minus 0.2. So it is minus 3.2 minus 3.2 divided by 0.2 minus 0.2. We have kept this negative sign right here. Okay, we have kept this negative sign right here. Actually the thing is I have made a mistake right here. I didn't write those things. I have written the right thing, but I didn't make you guys understand. If minus omega squared is equals to 2 pi by time squared, if we remove this minus and bring it right here, this minus will become positive. That's how we have made it. So now the gradient has come out as 3.2 divided by 0.2. This is our gradient. So now what we can do is we can write it again, that this 2 pi by time squared is equals to 3.2 divided by 0.2. Now what we can do is we can remove here 2 pi by time is equals to root over 3.2 by 0.2, and if we make time the subject, time is equals to 2 pi into root over 0.2 by 3.2. So our correct answer will be B. Yes, so we are done with it. Now let's move forward to the next question. Alright, in this question number 4 they have written a satellite of mass m is on the earth's surface. Okay, very good. A satellite is moved into a circular orbit of h above the earth. Okay, so let's say this is the earth, this is the center, and the satellite was at this position at first, which is 1r, and after that it was moved to a height of h. It was moved to a height of h above the earth's surface, above the earth. Okay, the mass of earth is m and the radius of earth is r. Okay, which of the following gives the change in gravitational potential of the satellite? The change in gravitational potential energy of the satellite when this satellite was moved from this position to this position. Okay, what is the change in gravitational potential energy? We know gravitational potential energy, the formula of gravitational potential energy is U is equals to minus gmm by r. This is the formula, right? This is the formula of change in gravitational potential energy. Okay, now I'm not going to derive this formula today. I'm not going to derive because this derivation is very basic and it is in your book. If you haven't learned this derivation, then please go to your book and learn the derivation, or go to your notes that you have studied. And the other thing is, if you haven't learned the derivation, please let me know in the comment box. I will make a separate video for derivation. Now we know gravitational potential energy is equals to minus gm by r, and now some students have a question why there is a negative sign right here. I'm going to explain that thing. Okay, the gp is negative here. The gp is negative because gravitational forces are attractive. The gravitational forces are attractive, and the reference point u is 0 is taken at infinity. Let's say at here in the infinity the u is 0, and if at infinity the u is 0, then anywhere between here, or even here or here, the gp will be negative. The u is 0 is at infinity. Let's say it is an infinity. At very infinity means it is very away from the center of the earth. At infinity the gravitational potential energy is 0, but anywhere in between the infinity and the earth's surface, the gravitational potential energy is said to be negative. That's why we have put a negative sign right here. So in this position at the surface, we can say in this position the gp is said to be u is equals to minus gm m by r, right, in this position. But when it was taken into height h, at that time the gravitational potential energy will be minus gmm by not this radius, because now the radius is with this r. Now the radius is along this r plus this height, so it is r plus h. This is the value, right? Now if we have to find the change in gravitational potential energy, this is the gravitational potential energy at the surface of the earth, and it is the gravitational potential energy at the height h to which this satellite was moved. Now if we have to find the change in gravitational potential energy, we have to subtract the final value with the initial value. Now what we can do is minus gmm by r plus h minus gmm by r. So this minus becomes a positive value. So minus gmm by r plus h plus gmm by r. So what we will do right now is we will write it plus gmm by r minus gmm by r plus h. So basically this is our correct answer, B. This is how we will derive the question number 4. Now moving forward to the question number 10, they have written a similar question has arrived in the October 2024 paper as well, where I have solved this question in a very detailed way. Still I will solve it right now so that you guys can go through it just before your exam, or just 2 or 3 hours, or just 6 or 7 hours before your exam, and revise them, because this is a very important question and it might be in your exam day as well. So please go through the October 24 paper as well. There is a more detailed explanation, and there is also some more questions as well regarding this. So basically what they have said right here is a particle is undergoing simple harmonic motion. Okay, very good. They have given us the VT graph. Of the simple harmonic motion. In the VT graph they have given, and they have asked to write the displacement time graph. We know speed is equals to distance divided by time taken. Okay, speed is equals to distance divided by time taken, and distance is equals to speed into time. In simple harmonic motion, specifically for simple harmonic motion, when the speed is 0, at that time the displacement is maximum, and when the displacement is 0, the speed is maximum. This is one thing that you guys need to memorize or remember for simple harmonic motion. When the speed is 0, the displacement is maximum. When the displacement is 0, the speed is maximum. Here, when the speed is 0, at that time the displacement must be maximum. For that reason, this is not maximum. Our A cannot be answered. Our C cannot be answered because the displacement is also 0. This displacement cannot be 0. The displacement needs to be maximum when the speed is 0. Here, when the speed is 0, the displacement is maximum. That's why this is our correct answer. Here, when the speed is as maximum, the displacement is minimum. That's why this is our correct answer. The correct answer is B. We are done with this paper as well. The simple harmonic motion of displacement time graph. And another thing is, when it is positive, it will be a negative graph. When it is negative, it will be a positive graph. And in the D part, the displacement and the speed, both of them are positive. So that's why, just because when the speed is 0, the displacement is maximum, but it is in the positive line. It cannot be in the positive x-axis. It needs to be in the negative x-axis. That's why B is the correct answer and D is not the correct answer. So we are done with this question as well. We will end this question paper solving session with this question number 7. Before doing this typical difficult question, I want to make sure one thing that you do is, your physics unit 5 exam is on 16th of this, actually on 15th of January, and your physics unit 6 exam is after 20th January or in 20th January. So you basically have around 5 days in between your physics unit 5 and unit 6. So basically in exam essentials, what I am doing is I am carrying out a 5 days question paper sprint way, where you will get my previously recorded physics unit 6 syllabus related videos, where there are 4 syllabus related videos along with 2 previously solved question paper solving videos. Along with that, you will get 5 question paper solving classes with me. You guys will get the chance to do graphs with me as well. So make sure you are joining this 5 days question paper sprint week to ensure that you are scoring above full UMS or around close to the full UMS, above A star mark or even a full UMS in your physics unit 6 exam. Because no matter how your physics unit 4-5 has gone, ensuring a full UMS in physics unit 6 will ensure that you are scoring at least an A in your physics, A to physics overall. Okay. And the other thing that I want to mention to you also is, I have a FAQ sheet made for the physics unit 6 exam as well. So you can also use that and utilize that by joining my question paper sprint week course. So without further wasting of time, let's start the question number 7. And another thing is that the detail will be given in the description box of the course outline, and my WhatsApp number and Facebook page exam essentials will be given there as well. So knock me in the WhatsApp or in our Facebook page exam essentials. So a mass oscillates with a simple harmonic motion. The mass has angular velocity of 2 radian per second. Great. It has a maximum velocity of this. They have given us the angular velocity and the maximum velocity, and they have asked us to figure out the amplitude. This is the same math that we have done previously as well. We know when V is max, angular velocity into amplitude. This is the formula that we know, that for maximum velocity, the formula is angular velocity into the amplitude. They have given us the maximum velocity as 10 centimeter s minus 1, right? And they have given us the angular velocity as 2 radian per second. And amplitude, they have asked us to figure the amplitude. The amplitude will be 10 divided by 2, right? So our correct answer is B. Now we are done with the most difficult, the most hardest, and the most typical common physics unit 5 multiple choice questions. If you want me to provide a video of physics unit 5 most important questions for January 2025 candidates, or a revision board video, if you want, then please comment down below and give a like button into the video, and please subscribe my channel so that you get more and more videos regarding physics unit 4, 5, 6, 1, 2, 3, even chemistry, biology, maths, business, and all other A levels, Edexcel and Cambridge subjects. Have a good day, guys. Thank you.